So we've talked about doing limits with a table, and I gave you a quick example about reducing and doing it algebraically, but this video is going to be about doing it graphically. So basically you're going to have graphs to mess with. So if you'll notice the first one, you can't see. All right, the first one is the limit as x approaches 5, sorry, my idiot dog is barking, of 7 minus x. Okay, so you should recognize that 7 minus x is a linear equation. It's a line that hits the y-intercept at 7 and has a negative slope, which means direct substitution works. Okay, so take if I know it says to use the picture, but I want to show you how, it doesn't matter which way you do it, it'll work. So I've got a 7 minus a 5. So 7 minus, evaluate at 5, and that gives you a 2. Okay, now, if you look at this, so again, your target is an x value of 5. So I'm going to creep at it from the left, getting really, really, really close from the left. So what y value are you creeping up to as I approach from the left? Well, I'm creeping up to a y value of 2. What about as I creep at it from the right? Well, I'm creeping up to 2. So here's the question. If I'm coming towards 2 this way, and if I'm coming towards 2 this way, does 2 equal 2? Yes, it does. So what's your limit? It is 2. Okay, so in this case, the value is the same as the limit. Okay, in other words, if I had said f of 5, you would have gotten 2. So the value is the same as the limit. Okay, so let's try it again. This one has an open circle at -1, and then it has a point below it with a y value of -2. So this is called a piecewise function, and this is, the top says x squared minus 1 as long as x does not equal -1. So this entire thing is a parabola that got shifted downward 1 unit as long as x doesn't equal -1. Well, what happens if x does equal -1? Well, then it has a y value of -2. Okay, so what's the question? The question is, what is your limit as x approaches -1? So this one, you're not going to be able to use direct substitution because remember, a limit is what you're creeping up to. So as I creep up to an x value of -1, okay, as I creep up to an x value of -1, what y value am I creeping up to? I'm creeping up to 0. Okay, as I come at it from this side, as I get closer and closer and closer to an x value of -1, what y value am I creeping up to? I'm creeping up to 0. Does 0 equal 0? Yes. Then your limit as x goes to -1 is 0. But if I asked you, that's your answer. But if I asked you, what is this if you shove in a -1, your answer would be -2. The value is -2. The limit is 0 because that's what you're creeping up to. Okay, so there's a difference. So your answer is 0. All right, so let's do another couple. This is going to be another one that's going to pop its head up several times, just this format. Okay, so you'll notice that it's the absolute value of x minus 3 over x minus 3. So I would like to know what the limit is. If you use direct substitution, you're going to get 0 over 0. Okay, so what y value, if my target is an x value of 3? So that's my x value of 3. So what y value am I creeping up to from the left? What y coordinate am I creeping up to from the left? It's a -1. What y value am I creeping up to from the right? It's a +1. So does -1 equal +1? No, it does not. Since -1 does not equal +1, your limit does not exist. So for WebAssign, you're going to put DNE. Okay? Now, here's the deal. We're calling your attention to the unique stuff. I could have asked you all day long, what is the limit as x approaches -4? So if x approaches -4, if this is my target, well then what y value am I creeping up to this way? It's -1. What y value am I creeping up to this way? It's also -1. So the limit would be -1 there. This is the unique thing, so that's what we're calling your attention to. Okay, so there's an infinite number of places on this where the limit does exist. There's one x value where it doesn't, and it's at -4. All right, so we have another one. we've got the limit as x approaches 5, and my answer, if I use direct substitution, I would get 5 minus 5, which is 4 over 0. That's undefined. This is not an indeterminate form. Okay? What that tells you is that there's an asymptote at x equals 5. So as I come at it from the left, where's the tail of my graph going? The tail of my graph is going to negative infinity. As I come at it from the right, where's the tail going? The tail is going to positive infinity. Does negative infinity equal positive infinity? No, it does not. So your answer is does not exist. Now I need to modify something for a second because you need to listen to what you're saying. You are saying the word limit. Okay? What are you approaching? You can never approach negative infinity because it's endless. You can never approach positive infinity because it's endless. Okay, so technically, if this were the picture of my graph, and if from the left it went to positive infinity and from the right it went to positive infinity, does infinity equal infinity? No, it doesn't necessarily, because you don't know what it is. Okay, so basically, if you're going to the infinities, your answer is it doesn't exist. And then we're going to throw a loop at you, I think in 1.5, I think it is, where we actually modify that a little bit. But for right now, if the tail goes to positive or negative infinity or both, your answer does not exist. Okay, so now let's look at this one. We've got the cosine. The limit as x approaches 0 of the cosine of 1 over x. Okay, so try direct substitution. That's going to give me the cosine of 1 over 0, which is undefined. So look at this weird thing that happens. As I get closer and closer and closer to an x value of 0, this thing bounces back and forth between positive 1 and negative 1, and it does it quickly. And what we call that is it's oscillating. Okay, like a fan. When a fan goes back and forth, okay, it's oscillating back and forth between negative 1 and positive 1. So since it never settles into a pattern, again, your answer is it does not exist because it never settles into a specific singular y coordinate. Okay? All right, let's try some more. All right, we have, this is asking, what is the value of the function when x is 1? This is not a limit. I want to know the coordinate. Okay? So what is my value? So here's an x value of 1. What is the y coordinate of the point that, what is on me? What is the y coordinate of the point that exists when x is 1? Well, its y coordinate is 2. Okay? That's algebra. The point 1, 2 is on that graph all day long. What is your limit as x approaches 1? So as you sneak closer and closer and closer to 1, what y coordinate are you sneaking up to? You're sneaking up to 4. Okay, so that's from the left. Now come at it from the right. As you're sneaking closer and closer and closer to an x value of 1, what y value are you sneaking up to? I'm sneaking up to 1. Okay, does 4 equal 1? No, it does not. So your limit does not exist. Okay, the limit doesn't exist because the y values that you're getting close to are not the same. What about f of 6? So I want a specific y coordinate when x is 6. So if x is 6, what do you notice you have? You have an open circle or it's undefined there. You do not have a point there. So since there is no point, it doesn't exist. Well, now come over here. What about my limit? So as I creep closer to 6 from the left, what y value am I creeping up to? Creeping up to 2. As I creep at it from the right, what y value am I creeping up to? I'm creeping up to 2. Does 2 equal 2? Yes. Then your limit is 2. That's what you're creeping up to. You may not get there, but that's what you're getting close to. Okay? All right, so you got to... Good heavens. All right, this one is going to be the same. I'm going to let you do this one because I'm trying to not overwhelm you with videos. All right, so remember, you're just going to give me a point if it's an evaluation, but you're going to tell me a limit. What am I sneaking up to? So be careful what's defined and what's not defined. And then let's look at this one. All right, so I got a piecewise function. So I look like a parabola to the left of 2. I look like a line that's going downwards between 2 and 4. and I look like a constant of 3, which is a horizontal line, after 4. So I'm trying to find out which picture this is. So I need to look for reading from left to right. I need parabola, downwards line, horizontal line. So here's parabola, here's downwards line, here's horizontal line. So he's a possibility. That is not a parabola, so it's not him. Okay? That is not a parabola, so it's not him. Here's parabola, downwards line, horizontal line. So he's a possibility. So now we just got to figure out who has the open circles and the closed circles. Okay, so first of all, if I shove in a 2, I need to know, does this thing hit? Because that's going to be, that's such a lie. All right, I need to know who has the open circle and the closed circle. And so that's the only difference here. This one has a closed circle. This one has an open circle. And so for my constant of 3, does he get an open circle at 4 or a closed circle? He gets a closed circle. So this is your graph. And now I want to kind of sort of get it a broader explanation. Where is the only place that this thing will have a limit that does not exist? So remember, find the unique stuff. So I can come from the left and the right all day long here, and I'll always be getting the same y values, right? Same thing. I'll always be getting the same y values. But what happens right here? When I come from the left, my y value will be 0. When I come from the right, my y value will be 3. So the only place where this thing has a limit that does not exist is going to be when x is 4. Okay? So what it's asking is this. Identify the values of c for which the following limit exists. Well, it exists everywhere, but not 4. So one of the things you need to notice is that a little c is going to be of a specific x. Okay, a little c is going to be a specific x. It's kind of like a variable of a variable. But we just use a lowercase c to denote that. So this exists at all points on the graph except for where x is 4. Okay, I can take a limit everywhere, just not where x is 4. All right, so I'm going to let you do this one because you can do that. Number 13 is a different type of proof. Keep going, hang on, keep going. Okay, so look at 18. This is where this starts up. This says, and I'm going to explain this in the next video, this is an epsilon and this is a delta. For right now, since the only question is what is the limit, I want you to tell me the limit. Can you draw a picture? Sure, I don't care. Can you make a table? Sure, I don't care. But what is your fastest, most efficient way? Your fastest, most efficient way is to use direct substitution. Okay? So the limit as x approaches 7 of x plus 1. Can I use direct substitution? Absolutely. So what is 7 plus 1? It is 8. Okay? Look at this one. What is the limit as if of 7? Holy cow. As x approaches pi. So if I graph 7, what does that mean? That means he's a horizontal line that slices through the y-axis at 7. And then pi is 3.14-ish. So what y value am I creeping up to from the left? I'm creeping up to 7. What y value am I creeping up to from the right? 7. So does 7 equal 7? Absolutely. So what's your limit? Your limit is 7. Okay. 20 I'll do on the next video. I'm trying to get this all in one video. 21 I'll do in the next video. 22. You can actually do 22 because it's going to be one of those 4 questions and then you'll take the limit. It's one of these 4 graphs. Okay. If you need to graph absolute value, hit math, scroll over to num, and option number 1 is ABS, and that's absolute value. Okay. And then the last one says find the limit. And then it says use epsilon delta to prove if you're right or not. Don't do all that crap because I'm supposed to teach you how to be efficient. Can you use direct substitution? So I'm going to shove in a -8. So I get -8 squared plus 8 times -8. So -8 squared, -8 times -8 is 64. That turns into a -64. So what's your limit? It is 0. And I'll probably hit this one back again, but hopefully you got it. Anyway, all right, so the last one is going to be epsilon delta proofs.